Hello programmers. In this video series, I will show you some good algorithms. With these algorithms, you can solve problems under their required time. In this video, we will solve some examples in which we will apply the binary search algorithm. So what is the binary search algorithm? It is a search algorithm that is used in a sorted array, in which we repeatedly dividing our search interval in half. Begin with an interval covering the whole array. If the value to be searched is less than the item in the middle of the interval, then narrow the interval to the lower half. Otherwise narrow it to the upper half, and we will repeatedly check until the value is found or the interval is empty. Let's take an example, then understand the concept of it. In this example, we have a sorted array from 1 to 11, and our target value is 8. So as the algorithm says, let's take the whole interval, take two integers which are pointing to the first index and the last index. Now the middle element will be 6. Is 6 equal to our target value? No, it's not. As you can see, our middle value is less than our target value, so we will narrow our interval to the upper half part. Now our first pointer is indexing to 7th element. Now again check, is the middle element is equal to our target value or not. This time our middle value is greater than our target value, so again we will narrow the interval, but this time in the lower part. Now our second index pointer is pointing to the 8th element. Now our middle element is 7, again checking that is our middle element is equal to our target value. No, it's not. The middle element is still less than our target value. Now again first indexing pointer will be pointing to the next to its mid element. At this time you can see our mid pointer, first pointer, and the last pointer all are pointing to the same element. Let's check the middle element again. Is this time the middle value is equal to the target value? Yes, this time we find it, our middle element which is equal to the target value. Great work programmers. Let's change our target value to 9 and continue our binary search journey with the same example. Now again we have to check our middle element is equal to our target value or not. No, it's again not equal to our target value, it is less than our target value, so we have to narrow our interval into the upper portion. Now our first index pointer is pointing to the 7th element. Now again we will check our middle element, is the middle element is equal to the target element? Yes, it is. Great, we again find it our target value. Now I have a problem if our target value is not present in the current array. Then what will happen? Let's take an example and find out what will happen. This time taking the same example without our target value in the array, which will be 3 this time. In the beginning, we consider our full interval, now checking the middle element which is greater than our target value. Now narrow the interval into the lower half of array. Now the last indexing pointer is pointing to 4th element which is 5, again comparing the middle value with our target value, and this time middle element is less than the target value, so now narrow the interval into the upper portion. Now our first indexing pointer is pointing to 3rd element which is 4, and also middle element is 4, again this time the middle is greater than the target value. Now again narrow the interval into the lower portion. Now our last indexing pointer is pointing to 3rd element which is 4, and you can see that our first is already pointing to that element. If we perform the process one more time, then our last pointer will pass the first pointer, that will our condition for the terminating the whole loop. If the first indexing pointer is greater than the last indexing pointer, then we will terminate our process. I hope you guys now have an idea of what is binary search and how it performs. Now the time for writing the algorithm for this, and then we will finally find its time complexity in terms of big O. Let's continue the journey or binary search with its algorithm. Let's make a function names binary search which takes 3 arguments, the array name, size of the array, and lasts our target value. First, we declare our first and last indexing pointer and assigning values 0 and size -1 respectively. Now the time for our main process, where first we will check our terminate condition and then proceed further, calculating our mid value and checking whether it is equal to or less than or greater than the target value. If our mid value is equal to our target value, then we will return either the index mid or true as per required, else if mid value is less than the target value, then we will increment our first to next of mid index, else decrement the last index pointer to the previous of the mid index. If our terminated condition passes, then while loop will be terminate and our control goes to the last statement, which is return -1, or you can return false as per required. Great, now you learned a super cool algorithm which is binary search. Now the time for the final step, which is analyzing the time complexity. As we know that after every iteration our interval size becomes half of the current interval. Let's explore it. At first iteration length of the array is equal to the size. At second iteration length of the array is equal to size by 2. At third iteration length of the array is equal to size by 4. Similarly for kth iteration length of the array will be equal to size by 2's power k. Also, we know that after k divisions, the length of the array becomes 1. Therefore n by 2's power k will be equal to 1. Or we can say n will be equal to 2's power k. After taking log base 2 both side, we got k equals to log n of base 2. So finally our time complexity is equal to big O of log n of base 2, or order of log n. I hope you guys enjoy this video. In further upcoming videos, I will upload some related topics. For that, don't forget to subscribe and also press the bell icon button for time-to-time updated. Thank you.